Good morning, good afternoon, and good evening, depending upon where you're joining us. I'm Robert Rich, and on behalf of my colleague Raphael Schoenle, we would like to welcome you to today's Inflation Drivers and Dynamics session. The session is part of the new Inflation Drivers and Dynamics Research Program at CEBRA and is sponsored by the Center for Inflation Research at the Federal Reserve Bank, Cleveland. We have 4 very interesting papers, and we're very excited to hear from our presenters. Before we begin, I'd like to go over some ground rules for the session. 1, each paper will have 20 minutes for presentation, followed by 10 minutes for questions and answers. There are no discussants today. Please submit questions using the Q&A function at the bottom of your screen. To help facilitate the process, please place the presenter's name at the beginning of the question, and you may submit your questions during the actual presentation. Each presenter will be notified when there are 10, 5, and 1 minute remaining in their presentation. I just have a couple of final remarks to make. First of all, we would like to thank our presenters and the audience members for participating in the session. And finally, as I mentioned at the beginning, the session is being sponsored by the Center for Inflation Research. The center is an initiative that was launched by the Cleveland Fed in December 2018. And if you've not done so, I would like to encourage you to visit the center's website. You can just type in Center for Inflation Research, and that'll take you to the website. And subscribe for periodic updates on research, conferences, and data products. So I would now like to turn the floor over to Raphael, who will be moderating the session. Once again, thank you so very much for joining us.
Thank you very much, Rob, and welcome everybody again. And I will immediately give the floor to Jim. So the floor is yours. Thank you for joining.
Thanks very much. Let me share my screen. So this is joint work with my colleague Anton Nakov. Usual disclaimers apply. This is a paper that is both an empirical paper and a theoretical paper. And we're motivated by this really curious pattern in retail prices. We're all accustomed as central bankers to assuming that prices are sticky. But of course, when you actually look at retail prices in the data, it turns out that they jump around a great deal because actually sales are extremely common in retail data in many countries and for many stores. And so there is a form of stickiness in this data, but it's very different from what we're usually accustomed to thinking about in Calvo type models. So there is one price point up here at the top. There's another price point down here, another price point down here. There's even a price point that started in this particular week. I'm hoping you can see my cursor. And that price point appears again and again and again through many years of data. The time down there is weeks. So the surprising thing about these data is that exactly the same nominal price appears again and again over a very long period of time. But then it, the price jumps up and down between these different price levels. Now, there are a variety of different theories, standard theories of trying to explain retail sales. One of the most important is stochastic price discrimination. If there's heterogeneous elasticity among consumers, then it may be optimal to randomize between several different prices instead of setting a single sticky price. And then another more recent model is based on rational inattention. It's known in rational inattention theory that you may minimize decision costs by randomizing across several different discrete points instead of allowing for many possible actions out of a continuum of options. Now, one of the things about most of the models that have been developed using these ideas is that they typically assume that you pay a fixed cost to set a plan. And so in particular, this is the case of Luminita Stevens's recent paper. So in her model, you pay a fixed cost. That allows you to set a plan, which is a set of different possible prices, and then you can randomize across those different prices. But if we saw that, we would expect to see all of the prices in the support of the plan. Every so often, we would expect all of those price points to be renewed. And I'm going to show you some evidence. You can see it just by looking at the data, but I'll show you some more systematic evidence in a minute. It doesn't seem that the whole plan is renewed at each point in time. Instead, individual sticky price points come and go. So really, we're going to try to set up a model that allows for decision-making of that type, okay? And so as I said, this is really both an empirical paper and a theoretical paper. On the theoretical side, we are introducing a new model of decision-making, which is a small extension of current rational inattention models. And then on the other hand, we're going to be looking empirically at whether price discrimination or something related to the cost of decision-making is actually the underlying explanation of sales. And actually, we're going to find that different aspects of the sales data seem to be driven by by those two motives separately, okay? And of course, ultimately, this is important for monetary policy because to what extent sales vary over time could have important implications for aggregate transmission of monetary shocks, all right? So I'm gonna jump on to just show you some data. So we want to look at the stickiness of not just an individual price, but of multiple price points that a firm is possibly randomizing between. And so the way that we can think of doing that is to look both at the backwards window of what prices have you set over the past capital T periods, and then also at a forward window of T periods and ask what prices do you set in that next window, okay? So when we see new prices come or go from the set, we can classify them. We can classify them as a transitory price change. That would be just a price that appears for one period and nothing else. Or we could classify it as a recurrence of a previous price or an introduction of a new price that's never been seen before. And then we further classify price introductions. I'm just going to show you examples of these three types of price introductions. So a type 1 introduction would be a new price where you don't see any other prices repeating at the same time. So this is a series that only has type 1 price adjustments, and that is to say it's just a single sticky price. But actually most products are not like that. So what is much more typical is products that have a lot of type 3 introductions. And what I mean by a type 3 introduction, those are all the red stars here. Each one of those is a newly introduced price that in the backwards and forward windows, you see some continuation of other price points that continue through the time of that introduction, okay? Now that turns out to be extremely common. What is much less common is introducing a new price in such a way that the entire support of all the price distribution changes, okay? So here is an example of a type 2 price introduction, which you might be able to interpret as a change of plan. But fundamentally, we find that those are very rare in the data. So this is just some histograms documenting the frequency of these different events at one particular store. But really, these kinds of patterns are seen in many, many different American supermarkets. This is basically typical. And so on the left, what we're doing is we're looking across goods and looking at the frequency of introductions, recurrences, and transitory prices, okay? We're putting the frequency of those three types of events on a simplex, and you can see from the histogram here that there are many, many recurrences. The recurrence of a price that you've set before, exactly that same nominal price occurring again is extremely common in the data, okay? Now, of course, there are also some introductions of new prices, And so then we also classify the frequency of the different types of introductions. And what we see overwhelmingly is that type 3 introductions are by far the most common in the data. That is to say, you introduce a new price point, but you don't eliminate all the price points that you were previously randomizing between in the past, okay? Sometimes a price point disappears, sometimes a new price point comes in, but we don't see evidence of changes of the whole plan, okay? All right, so I'm gonna build on rational inattention theory and control cost theory, which is the type of model that Anton, Nakov, and I have worked with in the past. And we're going to build on this in a way that very naturally gives rise to sticky price points of the sort that we've seen in the data. Okay, and so the key is that there are these recent results by Matejka and McKay, and then by Steiner, Stewart, and Matejka, which show that rational inattention models are simply a class of control cost models with optimal weights. So I'll show you what that means. So what do I mean by a control cost model? Well, I mean a model where decision-making, where precise decision-making is costly. So we think of a decision as being allocating probability over a set of feasible actions. And if you're perfectly rational, you should put all of the probability on whatever is the optimal action at a given point in time. But if you're not perfectly rational, that may be hard to do. And so we assume there is a cost function associated with the precision of the distribution of prices, okay? And the cost function that's convenient to use is relative entropy. So relative entropy simply measures how much your chosen distribution differs from some underlying benchmark distribution. And we will see that rational inattention theory then allows us to take that benchmark distribution from the data, okay? So a control cost problem, again, it's just maximizing the expected return to your action, given the state of the world theta, minus any decision costs. And since your first order condition relates the log of the probability to the payoff of the action, what this does is it generates logit behavior, okay? The probability of any given action conditional on the state is proportional to the value of taking that action in that state. All right, now, so that is to say that you have some errors in your decision-making. And for thinking about sticky prices, it's convenient that the sequence of decisions can be broken down in several different ways. You can think about it as I choose whether or not to adjust my price, and then if I adjust it, I choose which new price to set, or you can do it the other way around. It actually is invariant as long as you define the benchmark probabilities appropriately, okay? Now, that is very closely related to rational inattention. So in rational inattention, you also maximize expected payoffs, but now the cost is explicitly interpreted as related to information, okay? So under rational inattention, we're not assuming that you actually know the state of the world. Instead, you have to be trying to extract some information to learn the state of the world, and conditional on what you learn, you then choose an action subject to these information costs. But the thing is, mutual information is just a form of relative entropy. So exactly the same functional form that showed up in the baseline control cost model also shows up when you write the rational inattention model, okay? So, rational inattention also generates multinomial logit decisions. And the only difference is that now there is an explicit formula for what the benchmark distribution has to be. The benchmark distribution, the benchmark probability of any given action A should simply be the unconditional probability of that action prior to knowing anything about the state of the world, which is actually pretty intuitive, okay? Now I've said all of this in terms of a static model. This is the static model that was considered by Matejka and McKay. But actually, that static model can then be extended to dynamic contexts as well. So then instead of having a one-time payoff, you have some value functions that are entering into the decision, but it's exactly analogous, all right? And so for the purposes of our paper, what we found convenient was to take this a step further and introduce a very simple extension of rational inattention. So this in orthodox rational inattention, the decision maker has a memory of everything that's ever happened. More precisely, every single signal that they have ever observed, which is equivalent to every single action that they've ever played. Now, that turns out to be a very difficult thing to compute because it means the state space depends on everything that's ever happened in the world. So a simple model that is easier to compute is simply to instead say that decisions are going to be conditional on some set of signals observed in a backwards window, okay? Or equivalently, the set of actions that you took in the backwards window. And so we redefine the rational inattention problem in terms of a finite set of memories, and all the results of Steiner, Stewart, and Matejka still go through. Okay, so this is what we're going to use to model price stickiness, and this memory is going to be what ends up generating the stickiness of precise nominal prices. Okay, so now I'm going to dive into a model of monopolistic price setting. We have the usual demand function for a single good and shocks to productivity. And so ideally, the firm would like to be resetting its price in every period in order to track that productivity distribution, okay? But instead, we're going to assume that there are decision costs associated with that. And so the way to think about this is we just think of it as a two-step decision. In a first step, you decide whether or not you're going to adjust your price. That adjustment hazard is we're calling it lambda. And then in the second step, you choose a distribution over the possible prices that you will set if you adjust your price. Okay. So that is going to generate logit behavior, as I was saying, and this is the value function and the adjustment hazard in one example of that model. And so here's what we get when we simulate that model. By the way, I have not seen any signs of time. How much time do I have left here?
You have 5 minutes, about 5 minutes.
Thank you. Okay. So if you look at the model with no memory and with a constant demand elasticity, then basically what we're seeing is noisy tracking, noisy, sticky tracking. Okay. So the red series here is the cost shocks to the firm, and the blue series is the price that they set. So clearly it doesn't track perfectly, but roughly speaking, it has a fairly constant markup. And, we see sticky prices for brief intervals of time. And we occasionally revisit a price that we've seen before, but nowhere near as frequently as we would in the data, okay? All right. Now, we're also going to allow for heterogeneous demand elasticity, because that is what would drive the model if the cause of sales were stochastic price discrimination, okay? But so we start to get some sales when we put that in. And in fact, you can also see that then we have a time varying markup, okay? When costs get especially high, you end up raising your price and selling mostly to the low elasticity consumers. And so then the markup rises. And so this increases the volatility of prices somewhat, all right? But we're going to extend this to a model that really allows for sticky price points. And the way that we're going to do that is just further breaking down the sequence of events that, that we consider in the model. So in a first step, we're going to say that the firm decides, should I adjust my price or not? Okay, its chosen adjustment hazard is lambda. Then in a second step, we're assuming that this firm remembers some previous prices from a backwards window. And so in the second step, it says, well, should I just pick one of those prices that I remember from the backwards window, or should I pick any other price? Now, this may seem like a totally arbitrary way of breaking up the set of possible actions, but notice all of these things are events that we can actually observe in our data. Therefore, we know what are the unconditional probabilities of each one of these events, and that's what we end up using as the benchmark probabilities for those different events when we calculate the model. Okay, and that's exactly what rational intention theory tells us we should do. All right, so if I this will take just, there we go. So once you allow for this memory, you see that the distribution of prices that are paid, the prices that are charged, starts to become more discrete. And when you allow, in particular, for this sticky memory, and at the same time allow for heterogeneous elasticities, notice that the set of prices that are actually chosen in equilibrium starts to break apart into these two different regimes. Okay, so if you look at the price series that we generate from a simulation with both of these factors, then we have some very large sudden transitory movements, and we also have a lot of movements back and forth between exactly the same set of prices that we've observed before. Okay, so judging this against the data purely on the basis of the graph is a little harder. So I think the main punchline comes from looking at a few statistics. Okay, so basically what we find by comparing these, so what we're doing is we're comparing specifications without memory or with memory, and then we're comparing specifications with homogeneous elasticity or heterogeneous elasticity among the consumers. And so allowing for this finite memory, notice that it very greatly increases the frequency of recurrences. And so then it comes to be about 2/3, which is very similar to what we find in the data. And likewise, it makes these
Jim,
type 3
you may be out of
yes.
time very shortly, so if you could wrap up, that'd be great.
Right.
Thank you.
So this is the summary and conclusion. Okay, so we get recurrences and introductions similar to what's found in the data, as long as we allow for memory. And then what's needed in order to get sufficient short-run volatility is to allow for the sales motive. In other words, to allow for heterogeneous demand elasticity. So essentially what we're finding is that the stickiness of price points is mostly driven by the cost of decision making, but the great variability of prices between sales and regular prices is mostly driven by heterogeneous demand elasticity. That's the punchline right there.
Thank you very much, Jim. This is a really interesting paper. It addresses a lot of questions I've been wondering for a long time, seeing them in the data. So I will see, there's one question in Q&A. So I can read this to you, and then I have a few questions as well, or if you want to take a look. So it's a question from Raphael, I believe. So her question is, could the empirical findings alternatively be driven by a behavioral story on consumers? That is, consumers have left digit bias such that increasing the price from ending in 0.99 to 0.00 will result in a response in consumer demand that suggests a price 15 to 25% increase. So she has some data for that. So perhaps the stylized facts are driven by firms being fully information rational, but they're responding to behavioral consumers. you want to answer this now? Yeah.
Well, so that mechanism would actually be quite complementary to this, and I think it would. You could either assume that firms, or more likely consumers, have a limited capacity to think about numbers, and so they. I mean, I don't fully understand this thing of why everything has to end in 0.99 or whatever, but if there are a few focal points that are easier for consumers to process, or that firms can get relatively high profit from them when they set those numbers, then that could also help limit the number of points that you choose. Okay, I think so. That is a complementary explanation, and I'm not arguing that we've driven that out. In fact, it might be nice to add something like that onto this model. Of course, you would still need heterogeneous demand elasticity in order to make the price vary over time, instead of essentially always staying stuck for very long periods of time at a single price point. But that's a complementary form of information processing limit that would fit into this model. And I'm not going to try to say which one is the better explanation.
Okay, thank you very much, Jim. And I have two questions. Maybe there will be some other questions. So let me shoot first. So one is, you didn't really touch upon this, but it looked like your hazard function was increasing. So the further away you got from your steady state cost,
yes,
more like you were to adjust. So how should we reconcile this with the data? There's a 5 facts paper originally, right, showing that hazards might be actually decreasing, or some other patterns in the data that's like every 12 months, you adjust, but it's really the first month most of the adjustment takes place, and then that's a little bit of an issue, I believe, in general. So it might not be fair to ask you to address this here. And then my second question is about so some of the work that Roberto Rigobon has been doing is about quantum prices, right? I think which fits on the theory side with rational inattention. But so his finding there is that there's a particular set of prices that firms recur to, and it's a very finite set across a large number of products. So it's sort of like a refinement, I believe, to something like what you're proposing, or rational inattention. So my question would be how this fits with your model.
Well, I think the second question is very similar to the previous question from the audience member. That sounds like it's mostly more likely to be related to consumer side information restrictions, and again, I think that would be complementary to what we're doing, and I'm not hostile to that sort of explanation at all.
But it is a particular set of prices, like all the clothes cost like $79, and it's not just this type of consumer bias. So I think it's related to consumer behavior.
Yeah, exactly. I agree that that's more on the consumer side. I mean, I don't have a good theory of that. It just always seems like the consumers seem to focus more on the first digit, and the firm is better aware of the full price, and therefore they try to push the price as close to as high as they can, conditional on the first digit, conditional on still keeping a relatively small number of digits, so that it's not hard for the consumer to process. I mean, that would be my verbal description of what's going on. So again, that will definitely help reproduce the exact repetition of specific price points. And yeah. In fact, one of the points that we make in the paper is that pure rational inattention, as modeled by Matejka in his restart paper, is actually more likely to cause real price stickiness. His model generates finite number of price points that you bounce between, but the whole model is essentially defined in real terms. And so if there was any trend of inflation going on at that time, you would expect to see these prices smoothly increasing as real numbers instead of the nominal jumping back and forth to the same points that you get in our model, or that you get in a model like that of Rigobon. As far as increasing hazards are concerned, when I said increasing hazard, I was actually talking about in the space of in productivity space, or in the space of the demand shock, as opposed to as a function of time. So what our model does generate is that the further you get away from the optimal price that you would like to be setting, the more likely you are to adjust the price. So that would have some very mild tendency to cause an increasing hazard over time, as your cost shocks gradually drift away. But I actually think that is swamped by the shorter run incentives to be randomizing between different price points. So actually, given the kinds of demand that we're thinking about here, it's adjustments can be very quick, and there's indifference between or close to indifference between several different points in the support.
Yeah, perhaps you could
I'm not sure if I
investigate
got
this a little bit
far
more.
enough to answer your.
Yeah, I think it's a very,
question.
very difficult question, but I think it's important to have an answer. Right? You would also suspect that if there's some noise around these, or jumping between these price points, on average, you should still see hazard that's either increasing or decreasing, right? So my question was perhaps more about sort of the average relation, and that's I noticed you said mildly increasing, so I think there may be some dependencies on how you measure the hazard rates in the data, and I think there is a discussion about that, and also how this shows up in the model, or how you back it out from the model. What type of hazard? I believe you hinted at that.
Yeah, exactly, because here it's not just about a single price; it's about price points. And so, are you talking about the hazard of introducing a new price point? I think you would find, if you could control extremely well for heterogeneity, our model should imply that there's a mildly increasing hazard for the introduction of new price points.
This is super exciting. We have maybe 30 seconds left. So if there's no other question, I would say thank you very much, Jim. It's a really exciting paper, and Michael is going to be the next presenter.
Thanks very much. So I'm muting my.
Yes, thank you. And now, Michael, the floor is yours. Thank you.
Raphael, for this. Thanks for the organizers for setting up this session, and of course allowing us to present our paper here. As you can infer from the title, we are dealing with inflation and deflationary biases and inflation expectations, and more specifically as a result of losing confidence in the price objective of the central bank. And as this is joint work with Damjan and Pfajfar, I would like also to mention that, of course, the views expressed in this paper of us is not necessarily the view of the Federal Reserve Board. Why are we doing this? Well, of course, because we all know that losing confidence in the price stability objective has quite some implications. We know this for some time, that it makes the life of a central bank much harder if the audience or the general public deviates from the expectations the central bank wants us to have, and therefore makes them much harder to achieve their medium-term goals. And we know this, that this might happen in terms of an inflation bias. But quite recently, and given the unpleasant consequences of the financial crisis and the zero lower bound, we also realized that this happens when you're close to the zero lower bound. Fortunately, we know very little in terms of empirics, and given that the zero lower bound is not so old, we also not know or don't fully understand the consequence of it either. So in terms of contribution, we do two things here. First of all, we set up a model which allows for a certain heterogeneity of individuals, where their inflation expectations may deviate due to differential perceptions of the monetary policy, and more specifically due to the weight monetary policy might place on the output growth and on the output growth, and as well on the target of output growth they want to have, or the output growth gap, so to speak. And then we want to explore what happens if you lose in this kind of setup, that you have differential perceptions and the central bank, so you lose confidence. And we will see that in this kind of world, you get inflationary biases as well as deflationary biases in your population. So the overall distribution of expectations moves further away. You get greater dispersion because you suddenly have a block that has an inflation bias, and you have another block at the same time that has deflationary bias. And the second, I think this is the most important contribution here, is that we also provide some evidence of this. I mean, this while the theory or the world behind inflationary biases is already flying around for a while, there has been little evidence that losing confidence in central banks indeed drives expectations substantially. And we provide some evidence that this indeed is happening by a data set that is quite suited for this goal, because in this data set, we not only have short-term expectation, which you find nowadays quite in a few data sets on collecting survey expectations. Also, we have medium-run inflation expectations, which is of course much closer to the expectations. This is the maturity of expectations the central banks are aiming for. And at the same time, this survey questions or collect answers on how much you trust in the central bank, and not in a general fashion as this is done, for instance, by the European Commission survey, where they just ask if you trust the central bank. This survey instead is very specific in the question by asking about the price stability objective. So whether the central bank, we are confident, or the consumers are confident that the central bank will meet its price target on a horizon from 3 to 5 years. So we're able really to investigate the implications of losing confidence in this particular promise of the central bank on medium-run expectations, are of course very relevant for central banking. And this on a quite a wide scope, looking at 9 countries and having quite a substantial amount of observations here. So let's quickly sketch the world we are building upon to establish theory. The big difference, I see the bullet points 2 and 3, they're basically very similar to what we have seen before. So we basically borrow from most of the existing and established papers. The additional here is that we include the private sector, where we have heterogeneous expectations, and the expectations are basically driven by heterogeneous perceptions on the probability let's see, on the probability of having a large shock that pushes us closer to the zero lower bound, and different perceptions on the monetary policy objectives. And on top of this, we can see that everything else is quite standard. The only additional non-standard ways that we have here some kind of shock here, which was a Markov process. And the Markov process can lead us to a shock that drives us closer to a zero lower bound. So it is kind of a negative demand shock, you can think of it. And we have a population that is quite heterogeneous in the beliefs on this kind of demand shock, if you want to interpret this in this way. So we have different probabilities of affecting this. And if we take this kind of model, we can derive from this different hypotheses. First of all, we can get a situation where households can, or we have a population, a universal of households, where there are households that have deflationary biases, and we have households with inflation bias. And this kind of tabular nicely describes what's happening here. So if you have households that believe the output target is lower than a reference point, and they have quite a high perception that a negative demand shock can happen, so that pushes us closer to a zero lower bound, then their expectations will be very low, lower than the target. Instead, if we have households that believe the output gap is positive, and then of course the dominating perception is this higher output gap, then with this they will see that, or they will form rationally their expectations that are higher than the target. And this could happen at the same time. It really depends on which kind of dominant perceptions you have. Either you are under the group that is basically scared that we will have another shock while we are still close to zero lower bound, and it's not fully perhaps recovered and it's growing very high, then the dominating perception might be this high probability of high transition probability to a low state. And if in another situation you might be a type where you believe they have a positive output gap, and this of course coincides with higher expectations. Above this, you can also form other hypotheses, given that we have also data on some countries within the European Monetary Union. And within the Monetary Union, we know that it's the same central bank, so this Lamla, which is the optimal weight between inflation and output, that this should be the same because it's the same central bank. So everything that drives differences within the Monetary Union in a sample must be due to different perceptions of the output gap and the probability of having this negative demand shock. Finally, of course, as a consequence, if you are in such a situation where you have people with a lot of people who disagree, or a lot of people which have low confidence, then this increases the variance. And if you have a high population share of people that are confident in you as a central bank achieving the inflation target, this leads to a lower variation. So we can also make an implicit statement on the variation or the variance of inflation expectations we can test. So you can at at the end of the day, quantify what will be happening here. So let's, this is what our model tells us. Let's have a quick look on the data we're using here. So this micro data we have, so we have individual level data from YouGov. YouGov, some of you might stumble upon this, which is a company that specializes in market research. So they do a lot of surveys on a lot of more or less important topics, but they also provided us with this kind of survey. The good thing is that they're working internationally, so we get individuals from 9 different countries. We have a sample, so the survey stopped upon, unfortunately, at some point in time, but at least we have 11 ways within the period we think is quite suited for this. This analysis, remember, we need some kind of positive probability of a shock that drives us close to the zero lower bound. So we need to have a time where falling back into a recession or falling back to a situation where interest rates are zero has a positive probability to get a distribution with with an inflation bias at the same time as a deflationary bias. So I think we are this kind of time period is very much suited for this example for testing the model implications here. And finally, we have also quite a suitable amount of observations to conduct different tests here. In terms of the questionnaire, the first 2 bullet points summarize the question regarding the expectations. The nice thing here is that we have expectations that look at quite a short run and some expectations that are a bit more forward-looking here. And nicely capture basically the medium-run horizon of the central bank. So we can infer what people are thinking, what consumers are thinking in terms of inflation for a period that is quite the medium-run horizon we are looking at. And then we can map this with this kind of question on confidence. So how confident, if at all, are you in the country's central bank? So when it's not the monetary union, part of the monetary union, when it's not the ECB. So if you ask for France, it's then the ECB here. If you ask for the UK, it's the Bank of England. So how confident are you that the Bank of England, for instance, is currently pursuing the correct policies in order to meet its target of price stability? So the question is not about, is the central bank doing a good job? The question is very, very specific to the important bit that affects prices, and then this should, of course, then be best possible linked to the effect on the effect on expectations, and then they can answer not at all, not very, fairly confident, or very confident. And then we can already, sorry for this, just before we do the econometrics, basically just plot the distribution and have a look if there is anything in there. So let's have a quick look at this histogram. So what you see is the kind of reddish bars are those people that are confident, and the white bars are those people that are, or state that they are not confident. And what you see here is that you have a shift to the right in distribution, at least from some kind of 2% go to the right if you're not confident. So you have basically here the obvious result of an inflation bias. So people that state they are not confident, that they have slightly higher inflation expectations than those that say they are confident. But, and this is if you zoom in here, you can see also that people that are not confident could also have lower inflation expectation. I think this is the interesting part here. just by looking at the data and showing the distribution of expectations, you see both things happening at the same time, the same population. We have people that have higher inflation expectations and say they are not confident, but we have also people, and of course not so many as those people that have higher expectations, that have lower expectations. So basically just by looking at the data, it seems that both things are happening at the same time. And of course then in terms of distribution and steering expectations, we see that this really widens the distribution substantially by having both types. And then we could do the same now just by splitting the sample into expectations above 2.5% and below 1.5%, and calculating the means. And we see basically the same as we observe from the histogram. So close to the target, there's no difference, but we see that inflation expectations are slightly lower, even lower if you are below the threshold, and even higher if you are above the threshold. This is already an indication that inflation bias and deflationary bias can actually happen at the same time. And then we test this in a simple linear model where we explain expectations for the individual at region J at the time t with our not confident measure and some explanatory variables. Test for the hypothesis, we interact the not confident measure with being above or below, so being in this threshold below the target or being threshold above the target. And if this hypothesis should hold econometrically, then this we should observe an inflation bias at the above not confident coefficient estimate and a negative effect or negative sign at the below not confident estimate. And if we conduct this regression exercise, and please have a look at column 3. So there we have this above not confident and below not confident measure. We see that if you're above the target and you're not confident, your inflation expectations go up by 1.5%. If you're below the target and you become not confident, then your inflation expectations are even lower than this. And this is for medium run expectations. Like overall, if you just run the regression for the whole sample, you have this classic, basically in the aggregate, you have the classic inflation bias result.
We have about a minute remaining, Michael.
Yeah, I'm almost there. Many thanks. We also get, because we have countries that are not inflation targeters, we get this negative effect from negative inflation for inflation targeting, so they have slightly lower inflation expectations. But like you also like to stress this in this data, we can disentangle confidence in the central bank from confidence or trust in the government. Sometimes when you look in the literature, there's some kind of correlation or strong link between people that are confident in the central bank or just confident in institutions and people that are not confident in institutions. So they basically trust institutions or not. And we can even control for this confidence in central bank against confidence in governments. Just to wrap up, we see is quite percent heterogeneity for the EU countries, and as expected, this not confident or not confident substantially widens the dispersion of beliefs, which is of course negative, but this is something we observe from the histograms and also of course from the estimates. With this, I would like to close. Many thanks.
All right, thank you very much for this also very exciting presentation, Michael. Seems we're learning a lot today. So Let me see, there are a few questions, and I also added 2 questions. So let me remind you all that all participants can post questions in the Q&A section of the platform. So the first question is from Jim, who's saying, Michael, instead of asking whether people are confident that the bank will hit its target or not, wouldn't it be better to ask whether people expect the bank to undershoot, hit, or overshoot the target?
That's a good question, of course. But yeah, I mean, those questions are never perfect. We are very happy that we have one question, the question here that's quite specific on the inflation part of central banking. And I guess if you ask people if they are confident that you will hit the target, this also already means that you are quite sure that they missed their target by quite a bit. Therefore, it's somehow embedded, I guess.
Yeah, so I guess there's a little bit of this, like with all the survey questions, right? There's the question, how do you understand this exactly? So you could also think about whether hitting is actually the right perspective to take, right? Whether you could also explicitly ask whether you should hit the range. As we know, an average target, as we know, that might be relevant. So
yeah, I mean, last week, we have the Fed now changes also how to define hitting the target, right? So it would be.
So still, is your next paper, I suppose. So. And there's a question by Rob, which I believe you touched upon. So how much difference is there across countries with different experiences?
Oh, that's exactly a fantastic question. So we see that there's a difference. I mean, I showed you just quickly the graph on the EMU, because this was something we're really keen on. So even if you are an EMU country and you just mute one of the channels, this might cause a differential perception, how much difference you get. And we see that there is still some difference driving this. We are at the moment not sure how to interpret this thing and how to reason this, right? I fully agree. It would be nice to explain somehow the difference by perhaps lifetime experiences in inflation and any other things.
Yeah.
So this is a fantastic question again.
And Rob was also adding or asking whether your surveys offer density forecasts or they're just point forecasts.
It's just point forecast.
Okay, great.
Yeah.
And so, okay,
we have no uncertainty around this.
I see. So I believe we have time for more question, which I volunteered to ask. So did you also ask, or is there information about confidence or some measure of confidence question about people, you asking about other people in another country being confident about an object of interest?
Unfortunately, not in this survey.
Okay, I see.
In a different paper I did, we are exactly doing this, comparing the means and then asking how confident are you in this one. Yeah.
It would be interesting to see the contrast within the setting, right, of this very rich data, but I understand that no survey is perfect, obviously. So, okay, great. Are there any other questions? Oh, okay, great. This is very nice. Thank you very much, Michael.
Thank you very much.
And then we're going to move on to Emanuel. So if you can please unmute yourself and show your video.
Hi there.
Hi. Good to see you.
Share my screen.
Yes, please share the screen. And so the floor is yours, Emanuel. Thank you.
Thank you. So thanks a lot for putting our paper into this very interesting session. This is joint work with Carlos Carvalho, Stefano Eusebio, and Bruce Preston. It's a 4-continent collaboration that started while we were all in New York a long time ago. And I'm a central banker, so the usual disclaimer applies. This is a paper on anchored and possibly unanchored inflation expectations. And I would like to motivate the paper with a couple of charts. Here on the first, you see the evolution of US CPI inflation since the mid-1950s until just a couple of years ago. As the blue line, and as the red diamonds, you see short-term forecasts by professional forecasters from a survey of professional forecasters that was around for a long time, the Livingston survey. And what you can see is that basically professional forecasters tracked to a good extent the rise of inflation in the 70s and 80s, but also the sharp decline in the Volcker disinflation period, and basically track short-term movements in inflation also towards the end of the sample during the Great Recession, for example, fairly well. Now, somehow my slide, I cannot move my slides. Okay, this is very slow. Okay, I hope you now see another chart which shows again US CPI inflation from the mid-50s to the mid-2010s, and superimposed here now are long-term forecasts of inflation by professional forecasters. And what you see here is that first we only observed these long-term expectations since the late 1970s. Where we see that they do track to some extent the rise, the sharp rise of inflation in the late 70s and early 80s. And they also track the Volcker disinflation. But ever since the late 1990s, despite the volatile inflation process, long-term expectations by professional forecasters actually were quite stable. So it is quite challenging, we think, to understand the behavior of inflation expectations in both those episodes, the beginning of the sort of in the late 70s, early 80s, and in more recent years. And what our paper tries to do is essentially provide a coherent theory to explain those observations. So what we've seen in the recent financial crisis is that inflation was stable despite large negative output gaps. So inflation expectations seem to have been quite well anchored. However, anchored expectations of inflation are not an inherent feature of the economy, as we have seen in the great inflation of the 1970s and 80s. So a really crucial question for monetary policy making is, how do market participants, how do agents in the economy form long-run inflation expectations? And under what conditions are these expectations anchored or not? And unfortunately, most macro models don't really tell us much about these questions, because long-term inflation expectations in most macro models are either assumed to be constant, or they are assumed to drift exogenously and to be consistent essentially with policy objectives. So there's little room in the typical macro models for actually having inflation expectations, longer term inflation expectations drift like they did in the 70s and 80s in an endogenous fashion. So what we do in this paper is we build a simple model of inflation and inflation expectations that is based on learning. And the model has three key features. The first feature is that long-run expectations in our model are linked to short-term inflation surprises. So basically, in a model, price-setting firms try to disentangle low-frequency shifts in inflation from short-term fluctuations. And when they realize that they make short-term errors, forecasting errors, then they will adjust, after some time at least, the long-run expectations. The second key feature of the model is that this sensitivity of long-run expectations to short-term inflation forecast errors or surprises is state-dependent. It depends on essentially how long and for how much forecasters have been making mistakes predicting inflation in the short run. So expectations drift in response to large and persistent surprises only in short-term forecasting of short-term inflation forecasts. And the third key feature of the model is that expectations feed back to current inflation. So the inflation process in our model is partially self-fulfilling. And so that essentially delivers an endogenous inflation trend, which is affected by both economic shocks, but also by monetary policy. Now, after building this simple model of learning, we ask whether such a model can explain the evolution of long-term inflation expectations as measured by survey forecasts from surveys of professional forecasters. And we estimate the model using only actual inflation and survey-based measures of short-term inflation forecasts, which together give us a measure of short-term inflation surprises. And then we ask the model, what would long-term inflation expectations according to the model look like? And then we compare those with long-term survey forecasts for the US and also for a range of other countries that we observe since the in the last couple of decades. And what we find is that actually, yes, this simple model of learning is very well capable of explaining long-term survey forecasts of inflation, both in the late 70s and early 80s, but also in the more recent period when long-term inflation expectations were very stable and anchored. The model is a simple New Keynesian model. There's an output gap. And there basically an IS curve. There's an aggregate supply curve and aggregate demand curves. Firms are monopolistically competitive with some price adjustment costs a la Rothenberg. That gives rise to an aggregate supply curve. And there's a central bank. The central bank has a zero inflation target and uses a simple rule to stabilize a weighted average of inflation and the output gap with some policy shocks. That simple model is known to price setting firms in this economy, but price setting firms must optimally forecast the aggregate inflation process, and they do so following this simple process. What we assume price setting firms know is the data generating process of the economy, but not the inflation target. Why is this? Well, in some countries in the US until 2012, the inflation target, even if there was one, was not actually publicly announced. Forecasters could also think that the central bank lacks the commitment, the tools or the right incentives to implement the inflation target. So we basically assume there is an inflation target, but forecasters don't know it and have to learn about it from observing actual inflation. Now, assuming that forecasters predict aggregate inflation according to the simple rule, where there's a long-term mean of inflation, pi t bar, that they need to estimate from observable inflation data, the equilibrium inflation process will essentially feature exactly the same, or will follow a very similar DGP, but there will be a feedback effect from beliefs into the actual inflation process. And this feedback effect in the model depends on a number of parameters from the aggregate supply and the monetary curve and the monetary policy rule. So in a sense, the model features feedbacks from beliefs into prices. And as long as these feedbacks are smaller than one, the model is partially self-referential, if you will, in the language of the learning literature. Now, agents in this model use recursively squares to estimate this long-run mean of inflation, pi t bar. So they use a simple updating rule where they update pi t bar as a function of their past period's forecast errors, ft minus 1. And the gain which they actually use, or the weight which they apply to the past forecast errors, is this variable kt minus 1 inverse. Now, when agents are confident that inflation is a time invariant stationary process, they will use a learning gain in a model that basically is decreasing over time. Any additional new observation on the actual inflation will not make them update their inflation, their estimate of the long run mean of inflation very much. However, agents in our model doubt their own model of the inflation process. And once they have made sufficiently large and sufficiently persistent forecast errors, we assume that they switch to a constant gain learning algorithm, which basically attaches higher weights to more recent observations than to observations further in the past. And this is similar to learning papers such as Marcetta Nicolini, Cho and Casa, and others. So constant gain learning is a popular assumption in the learning literature. In our model, however, agents switch between recursive least squares and constant gain learning. Now, when do they switch? We assume that the gain is decreasing as long as a criterion is fulfilled that basically relates the subjective beliefs of the forecasters to the model consistent objective beliefs. And it turns out that we can rewrite this objective function as a weighted sum of all past forecast errors of the agents. And when that weighted sum exceeds a particular threshold, which we will estimate from the data, then we assume that agents in the model, price-setting firms, switch to a constant gain learning algorithm. So, and they do so in a sense to shield themselves from persistent or structural breaks in the data, or from basically from situations where the central bank may lack the tools or the commitment to achieve its inflation target. Now, in this model, over time, agents will learn the true mean of inflation, but it might take a very long time. And so along this transition path, expectations can drift away quite persistently in this model. Now, when are expectations anchored? After all, the paper is entitled Anchored Inflation Expectations. Well, inflation, we think of them as being anchored when agents learn about the constant long-run mean of inflation. So when they essentially apply this least squares rule of learning, and the sensitivity of long-term inflation expectations to short-term forecast errors decreases with time. We think of inflation expectations as being, as being unanchored when agents doubt the constancy of the long-run inflation process and put more weight on recent inflation. So when they use a constant gain learning algorithm. And in that situation, the sensitivity of long-term expectations to short-term forecast errors is large and does not change over time. Okay, we estimate the model first for the United States. We use Bayesian methods. The state-dependent learning rule makes the model conditionally linear, and so we use a marginalized particle filter, which is a very efficient tool in such a class of models. And I said earlier already, we fit the model using only short-term professional survey forecasts and actual inflation. And our goal is to evaluate the model's ability to explain long-term inflation forecasts that we observe in survey data, but that we don't use in the estimation. And we use the following data: CPI inflation at a quarterly frequency from 1955 through 2015. And we combine this with short-term forecasts, consensus forecasts from the Livingston survey and the survey of professional forecasters for essentially 1 and 2 quarters ahead horizons. I'm having some issue with switching to the next slide. I hope that you see the next slide now. Rather than showing you the parameter estimates, let me just make a couple of remarks about the estimated parameters. We find strong feedback effects. So this parameter gamma, which is a nonlinear function of other deep parameters in the model, and that measures the feedback from beliefs to the actual inflation process, is quite large. It's between 0.89 and 0.95, which means that there's essentially that changes in beliefs feedback strongly into changes in the actual inflation process in our model. In contrast, there's little intrinsic inflation persistence. As you may remember, inflation in this model is an AR1 process with a time-varying long-run mean. And this AR1 component here is fairly weak. The persistence in inflation really comes from the feedback effects from beliefs. Agents in the model switch to constant gain in response to relatively small deviations from the true data generating process. So our estimate of this threshold nu implies that agents switch when an average inflation essentially leaves the band of around 2 to 3%. And we also find that the constant gain in the basically regime when they use constant gain learning and doubt the constancy of inflation implies that less than 10% of the weight on observations that are 5 years old. So they really put a lot of emphasis in that regime on recent observations. Now here is the actual short-term inflation process along with the model implied short-term forecast as the black line, the solid black line. There's some shades around it, but it's very precisely estimated, especially at in the latter part of the sample. And on top of and then we superimpose the observable short-term forecast errors 6 months ahead from the Livingston survey. There's 2 different basically horizons here. And as you can see, the model tracks these short-term forecasts of inflation quite well. Now, what does the model imply for long-term expectations? As you recall, we don't use long-term expectations from surveys in the model estimation, but basically ask the model to infer long-run expectations of inflation and then superimpose here in this chart the observed long-run forecasts of inflation from 2 different surveys, the SPF and the blue chip survey. And what you see here is that basically the model, even though it does not use long-term expectations of inflation, fits these long-term inflation expectations fairly well. It captures the sharp run-up of inflation and long-term inflation expectations in the late 70s, but also the sharp decline in long-term inflation expectations in the process of the Volcker disinflation period. It also matches very closely the very stable long-term inflation expectations that we have observed ever since the late 1990s. Now here's a chart that shows the learning gain that we derive from this model over time along with the posterior probability bands. And what you see is that basically through the 70s, 80s, and until the mid-1990s, agents in our model were not sure that inflation is a stationary process and used constant gain learning, so putting a lot of weight in their forecasting procedure on recent observations. Ever since the late 1990s, however, they have switched to a decreasing gain algorithm, basically thinking inflation is a stationary process. And so new additional observations on inflation have resulted in little forecast revisions of inflation. And hence you have this very stable long-term expectations of inflation.
A little less than a minute remaining.
Thank you. At the end of the sample, despite very volatile inflation process itself. We do a couple of exercises in this with this model. We essentially ask what happens if you turn off the feedback effect that is inherent in this model. And you see that here, if you do this, basically the model misses altogether the run-up of inflation in the 70s and 80s, and also implies too volatile inflation, long-term inflation expectations at the end of the sample. Using only constant gain learning also has a number of downsides. You also don't match the run-up of inflation expectations in the 70s as well, and constant gain learning gives you too volatile long-term expectations towards the end of the sample, especially in the Great Recession. We then also use the model to estimate implied long-term inflation expectations for other countries using essentially the US posterior distribution as a prior, because for these other countries, especially European countries, but also Japan, we don't have inflation expectations data going back as far. I will not have time to show you all these results, but basically let me just tell you that the model characterizes well the evolution of long-term forecasts in all of these countries. It always shows that the expectations or implies, consistent with the data, that expectations were more stable beginning in the 1990s, with some episodes of unanchoring, however, both in Japan, but also according to our model in Switzerland. And with that, let me just conclude by summarizing that in this paper, we have built a simple learning model that links long-term inflation expectations to short-term forecast errors. In the model, inflation and inflation expectations can become unanchored in response to large and persistent short-term forecast errors. The model implies that long-term inflation forecasts that are very well in line with survey data for various countries. And so we think that this is a nice model to basically capture both the unanchoring of inflation expectations in the 70s and 80s and the anchoring of inflation expectations in more recent years. Thank you.
Thank you very much, Emanuel. It's another fascinating paper here. So we have a little bit of time for questions. The first one is from my colleague, Randy, who is asking, how are you measuring market expectations? Are you using medians or the average? And can you explain divergence of views?
Yeah, so this is a paper where we really only focus on the consensus. Where available, we use the median, but sometimes only the average is available. This project does not look at disagreement among professional forecasters. We have other work where we look at the term structure of disagreement among forecasters, but not in a learning context, more in the context of informational frictions, such as noisy information or sticky information. In this model, we cannot say anything about divergence of beliefs. There's essentially a representative agent price setting firm whose expectations we model here, and we then fit this to short-term expectations from surveys of professional forecasters. Unfortunately, we don't have firm expectations going back as far. Ideally, we would, of course, do this with firms in inflation forecasts, but we don't have these data going back as far.
Great. There's another question from Rodrigo Guimarães, which is the following. The UK is a conspicuous absence in your sample. It has good data or better data than many countries, including, and more interesting changes in monetary policy frameworks than most. So inflation targeting, different events, many years apart, and substantial variability over time, similar to the US, but differences are interesting. Why was it not included?
You know, that's a good question. I don't recall having explicitly taken out the UK. So I have to pass on that one. We have used the consensus economic survey data. Maybe there was a limitation in terms of the observations of short-term inflation expectations for the UK from that. I will have to pass on that question. I don't recall. There was no explicit reason that I remember for leaving out the UK. I'm supposing it was a data availability issue, but I cannot really answer.
Yeah, so usually that's probably the thing you don't remember, because it's so obvious. There's one other question, I think, by my colleague Rob Rich. I'm not sure if you can post it, or Rob, if you would like to ask your question yourself.
Yeah. Hi.
Rob, yes.
Can you hear me? Hi, Emanuel.
Hi, Rob.
I'm just going to ask the question. It's going to be easier than typing without having enough coffee this morning. So I was just curious. I mean, the definition of anchored inflation expectations, there seems to be a lot of different definitions. For example, you know, there's a paper by Grushenko where I think they look at sort of a density forecast and how much of the density forecast sort of is covering what the objective happens to be of a central bank. And then I guess if I think about anchoring, I mean, you could even within a particular sample, right, you could have individuals moving around quite a bit, but in some sense, the consensus or the median measure might not be moving very much at all, right? So, I mean, I guess that there are these higher dimensions, like, I think we think of anchored inflation expectations as an easy concept until we really think about it in more detail. And it seems like there are these other subtle dimensions of it that you know, sort of, you could think about sort of weak anchoring versus strong anchoring and things like that. So I guess I just wanted a general thought in terms of kind of these different ways of thinking about the concept, because as you said, I mean, as you know, it could be thinking about how much of a density forecast covers the inflation objective, how much literally the individual forecasts are not moving relative to kind of bouncing around and things like that. So just any sort of general feedback or comment on that would be greatly appreciated.
Yeah, that's a great question. I mean, we're well aware of the various different things people have in mind when they talk about anchored inflation expectations. We very much define it in the way that Bernanke did in a speech in 2007. And actually, at the beginning of the paper, we have a quote from Bernanke that I just try to share right now. I took it out of the slides because I didn't think I would have time in 20 minutes, but that's usually how we also motivate the paper and presentations. So what Bernanke was saying, and that's very much our view of how we interpret anchoring of inflation expectations, is that he says that anchored inflation expectations, or anchored expectations more generally, are relatively insensitive to incoming data. So when you see shocks hitting, you basically don't really update your estimate of the long-term mean of the process. And so that's exactly what we believe has characterized inflation in recent years in most developed economies. That basically, despite the large volatility of inflation, really large output gaps, for example, in the Great Recession, long-term inflation expectations have been fairly sticky, and so we think that they have been anchored, or in the sense of being insensitive to these incoming data, whereas in the 70s and 80s that was not the case. So that's essentially the definition that we follow. I agree there's others that target more sort of that think about anchoring more in terms of the uncertainty around inflation, or the disagreement among different agents. Here we really want to think about anchoring as meaning insensitive to shocks or to incoming data. And that's exactly what we try to model, both in the little theory model, but also basically in the empirical work that estimates this model, where we just basically make the updating of inflation expectations dependent on the short-term forecast errors. And when these short-term forecast errors deviate or are basically large and persistent, then expectations become unanchored in our model. I hope that answers your question.
Yeah, that was great. Thanks, Emanuel.
Okay, great. Thank you very much, Emanuel. I believe it's actually time to move on to the next paper. Our next presenter is going to be Michael Weber. Thank you very much, Michael. The floor is yours.
Thanks a lot, Raphael. Thanks a lot, Rob, for including our paper in the session. This is joint work with Olivier Corbiot at Austin and Jörg Rodnichenko at UC Berkeley. And to motivate our paper, let me see, is it not moving? To motivate our paper, I have two quotes from central bankers from, I would say, different generations. So the first one, Alan Greenspan, who at some point famously said that, you know, if you thought you understood what I said, you must have misunderstood me. Whereas Jay Powell more recently was saying, well, you know, given that monetary policy ultimately affects everyone, let me actually try to summarize in plain English what we are here doing among my friends at the Fed. And so I think it's a fair characterization. Most likely many of you would agree that there has been a dramatic shift in the shape and type of communication by central banks over the recent decades. But I think actually it's also fair to say that still quite a bit of the central bank communication has been focusing on financial markets, And there are good reasons for that. On the one hand, you might be concerned about financial volatility. You might want to actually curb that, or you might have an idea. Well, ultimately, my policy instrument is a short-term interest rate, but if I actually am able to commit and credibly convey to financial markets, that I might actually keep that policy rate long for low, low for long. I might also somehow have an effect on long-term rates, maybe by an expectations hypothesis. And by now, I think actually we have very credible evidence that indeed actually forward guidance and communication has been quite powerful in moving financial markets. Yet, and I think it was partially also shadowing through from what Emanuel said, that at the end of the day, when we write down models, at least the models I write down, there's typically, there's no professional forecaster, there's no financial market in there, and we somehow try to, rely on some indirect arguments why we might actually want to focus on these type of expectations. And maybe actually you could even easily say, for, let's say, borrowing money and buying a house, ultimately what's crucial for me is maybe long-term interest rates, and so therefore to affect household decision, I actually might go indirectly through financial markets. But what we've actually done in some recent work using Finnish data, we actually showed that many households, especially so in the lower parts of the IQ distribution, do not actually seem to react to movements in interest rates. So maybe, this indirect transmission, at least for parts of the population, might be clogged up. Then on the other hand, you could say, well, maybe, we might want to actually be less ambitious for households to the extent we are somehow able to anchor the expectations. Actually, that's maybe all we want to do, but I'll show you later some evidence which seems to be, at least for households, maybe less, ensuring that what we saw from Emanuel's paper. And then you could say, well, maybe actually, and this is also what J. Paul at some point had said a couple of years ago, he said, well, when I talk to my friends at cocktail parties and tell them that I'm now the chair of the Federal Reserve, they ask me whether this is a part-time job. A different way of saying that, maybe people have no idea what the Fed is doing because in their day-to-day decisions, inflation or monetary policy doesn't really matter all that much. But then, of course, this is not totally innocuous in the sense that if you're in times right now where maybe one of the few or maybe the only game in town is communication and forward guidance, if people have not even an idea who you are and what you do, maybe actually it's somewhat challenging to hit through the veil of ignorance. So let me actually just tell you in a few slides what we're doing. So if you've seen Dimitris presenting in the previous session, very similar setup than in his paper. So we run a survey on the AC Nielsen home scan panel, where we just do an information treatment experiment, split the sample randomly into different subsets, and then actually just randomly provide different subsets of the survey population, different pieces of information. First, elicit expectations, provide information, elicit expectations again, and then we want to see whether different pieces of information leads within individuals to an updating expectation, and crucially also directly sucking up any variation in the control group due to different question designs. Now, let me just tell you what we find. So if you just tell people very random statistics like current inflation is, or the Fed inflation target is, those type of statistics have actually lots of power and are very powerful in moving average expectations all the way up to 1 to 1.5 percentage points afterwards relative to before information treatments. And if you were to take those expectations and say, well, look, what do those changes in expectations mean in movements in perceived real interest rates, and compare that to the power of QE and forward guidance on financial market outcomes such as real interest rates? Of course, those type of movements are way bigger than anything we've estimated in financial markets. If instead you would say, well, as the Fed, maybe we don't have to talk directly to people. We could directly instead rely on the media to asking us questions in interviews and Q&As, and then they might actually convey our message to the people via newspaper articles and the like. In our paper, at least, find that for a specific newspaper article and incidents, actually this traditional transmission mechanism was actually way less powerful. And so let me now tell you a little bit more in terms of details. So there is a Nielsen home scan panel. Think about, panel of 40 to 60,000 Americans in the US spread out across the whole country, where you have a very rich set of information: age, income, marital status, number of kids, job, college education, and stuff like that. Then, and this is a nice part of the panel, you know, for any type of good, I don't have anything here with me now, well, not really a lip balm, well, which has a barcode that you purchase in a grocery store. Those guys would actually go home, have an optical scanner at home, and then start scanning whatever they purchase, so you know exactly what did they buy, how much did they pay, did they use coupons or not, which type of grocery outlet did they buy. And then actually Nielsen runs in this very panel small-scale surveys on a month-to-month basis, but then also on the overall panel, more customized solutions, which are typically used, let's say, think of Coke, planning to introduce a new variety of Coke, and to ensure that they don't run into another marketing debacle, they would actually try to pre-test the new variety on that panel. And so as part of an ongoing project, which together with NBR, the National Science Foundation, we've been running quarterly surveys over the last couple of years. And for the current paper, we focus on waves in June, September, and December of 2018. And one of the nice features of this panel is just sheer size. You know, you can actually randomize many different information treatments and still actually look at subsample analysis, which of course in smaller scale surveys that are commonly used in the literature, which of course have many important applications. However, something like this would not be feasible in those type of surveys. Let me just tell you a little bit about you know, the sample. So for all the waves, we've got a response rate of 1/4, which is actually pretty decent compared to what, for example, Qualtrics, which is one of the biggest provider of private sector service, which estimates like 5 to 10% response rate. So just to give you an idea, we have about 25 to 30,000 respondents. So it shows you already that actually we can really drill into different type of demographics. In terms of things, we also listed over and above the demographics from Nielsen, so things like financial constraints, gas price expectations, also who's doing the grocery shopping, because those things are important. Now, in terms of actually the key outcome variable we are looking at, we focus on inflation expectations, and we directly ask about inflation, given the evidence from the New York Fed. So with consumer expectations that on the one hand people have a good idea, but on the other hand also leads to less biased expectations than the Michigan survey question. And then not only do we ask for point estimates, but also full probability distribution. So think about a distribution ranging from -12 to +12, bin size of 2 percentage points, and then you ask individual survey participants to allocate mass summing to 100, and only once the whole mass is distributed, they can continue. And then, as we said, you know, you elicit priors, you split the sample randomly into different groups, 8 information treatments, 1 control group, and one of the treatments actually placebo treatment, where we want to actually disentangles actual learning from spurious learning due to things like survey demand effects. And then subsequently, we elicit expectations again, both immediately after information, but also after 3 and 6 months to look at some persistence in treatment effects. Now, in terms of information treatments, first a couple of summary statistics: current inflation, forecast, target. Then we force them to read the FOMC statement, a coverage of the FOMC statement in the USA Today, then also current unemployment numbers, gas price, inflation, and finally, as a placebo treatment, the true fact, because we cannot actually lie in these type of surveys, of course, that the US population grew by 2% over the last 2 years, which of course at least there shouldn't be any direct strong effect on inflation expectations. Not just an excerpt from the FOMC statement. This is about, you know, 1/3 to about half of the actual length. Crucially, also the overall relevant sentences here are highlighted in red. So at the end of the first paragraph, if you read, you learn that, you know, core inflation and overall inflation has moved close to 2%, which is also the target. USA Today, the only thing we cut here is a single sentence, so way shorter. more early on in the paragraph, you see actually that current and goal is 2%, so it's overall easier to digest and figure out what the relative numbers should be compared to the FOMC statement. That's the only thing I want you to keep in mind. And then, as we said, prior, treatment, posterior, and what we now want to just do, this is a couple of summary statistics. On average, upward bias, lots of dispersion, women higher than men, as is standard in those type of surveys. Earlier, already foreshadowed a little bit, if you were to ask people, what do you think is inflation rate the FOMC tries to achieve over longer periods of time? And then you plot the answer. On the one hand, you see, well, there's a little bit less than 20%, which seem to have a good idea what maybe an inflation target is. And you also ever see that it's almost 40%. And here we are just spinning everyone that has an answer larger than 10% that actually thinks that the Fed tries to achieve inflation over longer periods of time, or used to try to achieve equal to larger than 10%. So now empirically what we do, so we just say, well, let's look at the forecast revisions as a function of my treatment relative to the control, with set of demographics, standard observables. Let me not spend too much time on here. And later on, we also look at, instead of actually just the average revisions, on different specifications, but to the extent that most of our survey respondents have actually priors that are above the treatment, so we can still actually meaningfully look at average revisions and expectations, which of course, if they were symmetrically distributed, wouldn't make too much sense. So here just, is there any anchoring? The answer is yes, but it's actually less than 1/10 of the cross-sectional standard deviation. So therefore, whatever you see may be directly put in reference to the effect, treatment effect of population growth. Simple summary statistically to revision and expectations between 1 and 1.3 percentage point. This is true for raw revisions, but also conditional and observables. FOMC statement, similar magnitude, even though you have way more information, just actually the same as those simple numbers. Instead, actually, if you make it easier for people to understand, at least that's what our FIRE would have been, it looks like actually people systematically discount the information coming from USA Today. Ex-ante, people have a perception of unemployment higher than it actually is. If they had a Phillips curve in mind, you would expect they update upwards, instead they update downwards, more consistent with the supply side view, or what Raphael and others have shown that there may be good bad associations between different variables. Gas price inflation, ex-ante high inflation expectations, to tell them very high gas price inflation, update even higher. Now, in terms of persistent, after 3 months, about 3/4 of the effect is gone. After 6 months, all of it is gone. Now, this could be just a reflection that, maybe those treatments are weak. Maybe, however, could also be the case that people forget. For some of the treatments, we also had priors like inflation target, current unemployment rate, and current inflation. So we can see whether after 3 and 6 months, people actually recall what we had told them. And the answer is similar to our actual treatment effects. If you tell people information like current unemployment rates, they just tend to forget after 3 months to a large extent, and fully forgot what we told them after 6 months. Now, one of the things we saw in the data is that especially this newspaper treatment was systematically discounted. Now, one question could be, well, maybe it's just the source you chose in USA Today, which we had originally picked because it's a non-partisan newspaper, but maybe people think it's just a crappy newspaper as a source of information. So what we first did, is it about newspapers? If you look at least credible, most credible 1, least credible 5 different sources, you see that actually newspapers are the least credible, social media the most credible, at least currently in the US. Within newspapers, you see actually USA Today more credible than Wall Street Journal, New York Times, Chicago Tribune, LA Times even actually more credible, but those are also more regional newspaper in the sense that actually the biggest chunk of the survey population thinks actually they have no idea whether those outlets are a good source of information. Now, it looks like if you were able to reach the population, you might be very powerful in shifting expectations. The effects, however, are pretty short-lived, meaning that one of via media seems to be partially clogged off. So we might have to figure out more direct ways of communication. So now in the last few minutes I briefly want to look at a couple of heterogeneity splits, because on the one hand, maybe actually are concerned some reacting, others are not reacting. It could lead to maybe some form of redistribution, or maybe you want to think about more targeted communication tools, or maybe target those that react the most. In the end, in the appendix, we've done tons of splits. The only ones that actually did seem to matter are the ones I show you now. First thing, gender. What you see is that women, for everything, including placebo treatment, are more reactive compared to men. What we see is actually men have tighter priors, which, especially in the behavioral finance literature, people have interpreted as more overconfidence. You know, I don't want to put too much interpretation in now. Just in general, you see women more responsive. You also see in terms of income, it's the middle income distribution that tends to be most responsive. Whatsoever maybe also a little bit concerning is it's the bottom of the income distribution that does not react at all to the newspaper treatment. It's not because they cannot read or write, because they just react the same as high income individuals for the FOMC statement, but not for the newspaper coverage. Very similar in terms of education, no reaction for the lowest educated. The newspaper coverage, they however do react identically to the FOMC statement. So again, it seems to be peculiar of distrusting newspapers as a source of information, the specific newspaper at least. Now in terms of reaction, so far we looked at an average response, but we might also think that maybe everyone is a Bayesian updater if the prior were distributed symmetrically around the signal, and then we might not see an average updating, but a shrinkage in dispersion. So one way of looking at that, we look at a measure of the mean absolute deviation in terms of pre-treatment, very similar relative to the control. Immediately afterwards, we see numbers smaller than 1, which are directly expressed as a function of the control. So therefore, we see shrinkage, but again, similar to average updating, we see that after 3 and especially after 6 months, pretty much nothing actually remains, so the overall effect has dissipated. Now, in terms of margins of adjustments, we saw earlier that people seem to react less to the FOMC statement. This could be driven by a smaller fraction reacting or conditional on reacting. Maybe people react by less. Let me just show you some way of looking at that in terms of first 2 columns, extensive margin, second set of 2 columns, intensive margin adjustment. And at least to a large extent, it appears that it's not that a different fraction of people is reacting to the USA Today coverage, but at least it seems like conditional on adjusting, people systematically adjust by less or discount this information. And as we discussed earlier, most have actually priors that are above 2%. It's only about maybe a quarter to a third of priors below 2%. You see that pretty much all the adjustment is coming from those that have priors that are above the type of information we provide. So let me wrap up. So what we try to do is here is design and implement a survey experiment in which we provide different forms of communication or information about inflation to see actually who is responding, how strong are they responding, is there heterogeneity. And I think the key takeaway is, on the one hand, if you want to communicate to individuals, you have to find ways to directly reach them, conditional on reaching them. You can move expectations quite dramatically, but the effect is short-lived, so therefore you might have to engage in somewhat of more persistent type of communication strategy.
Great. Thank you very much, Michael, for this interesting presentation. I have one question here, and then I also have a question of my own. Let me first read the question to you. Sorry, it just disappeared from my screen. It was from Rob Bridge. Rob, would you mind at all just asking?
I have it in front of me, actually. So it's about, Are you surprised that almost all information provided to individuals, with the exception of gas, causes them to revise the inflation expectations down? How do you think about it? Do people have an upward inflationary bias? And I think actually your question directly provides the answer ex ante. You see that households have expectations that are substantially above exposed realization in inflation. And for example, if we were just to plot over the last almost decade of data now, data from the New York Fed Survey of Consumer Expectations, and don't do any censoring or whatever, just raw data, you see that the average expected inflation rate is, I think, even above 5%, 5.2, versus realized inflation, as we know, over the last decade was barely actually scratching the 2%. So there is a substantial upward bias, which ultimately explains why you see that pretty much everyone is revising downwards the expectations.
Yes, that's very interesting. So if there are no other questions, I will go ahead. So I think I'm always fascinated by seeing that there are many people who have extreme beliefs from our point of view. The guys who say it's going to be more than 10% inflation, and you know, from various sources, it seems to be very persistent across many data sources, managers, and so on. Can you also observe or tell us a little bit more about these people? You know, do they revise also most quickly upwards and downwards, and different horizons, and some? Is there anything particular about them that we can learn?
Well, so one of the strongest observations in terms of demographic determinants that actually seems to explain heterogeneity in inflation expectations is gender. So women actually have a higher upward bias than men, but this has nothing to do with women being less informed or have different capacity of processing information. It seems that it's just driven by traditional gender norms, as we argue in a recent paper with Francesco da Cunto and Ulrike Malmendier. It's about 3/4 of all shopping is done by women, which exposes them to the very volatile prices in retail, and given, and this is consistent with previous work, that individuals mainly focus on positive price changes rather than negative price changes. This actually imposes women to, on average, larger positive price changes compared to men, which then helps us understand this gender expectations gap, especially in the domain of inflation expectations, which then consistent with what you actually just saw. It's also that women actually update stronger once you actually tell them objective information.
Okay, oh great. I mean, there's a lot to learn for policy making, I believe, from having such rich data and careful analysis. Okay, are there any other questions? If not, I'm happy to conclude the session. It's been a long morning, a long day. So thank you very much, Michael. Thank you, everybody, for presenting and everyone for asking questions. And we hope to see you next time at the next IDD session. And that's it from my side. Thank you.
Thanks,
Bye-bye.
everyone.
Thank you. Take care.
Yeah, thanks very much to everybody. Thank you so much.